Hello, and welcome to the tutorial series for TIBCO Data Virtualization, or TDV. In this tutorial, we show how to use Couchbase as a TDV data source. Note that tutorials are not meant to be comprehensive training modules. Instead, they demonstrate a very basic use case that can be built quickly and easily. However, the Community Edition knowledge base contains additional information that will help you learn more and go deeper. Additional resources in the knowledge base include resources used to build the tutorial, such as data virtualization archive files, data source files, and a document version of this tutorial. Additional information, including documentation and training materials. Here is our agenda. We begin by defining the Couchbase Data Source and explaining why it is important to TDV customers. Next, we walk through a very basic demo using Couchbase with TDV. Finally, we summarize the contents of this tutorial. Let's begin by discussing what Couchbase is and why it is important to TDV customers. Couchbase is a NoSQL database that stores data as JSON documents. Couch is an acronym for Cluster of Unreliable Commodity Hardware. Couchbase is schemaless, making it very easy to extend documents by adding new data elements over time. Related documents are typically stored in individual databases, which are called buckets. Couchbase provides a query language called NQL, which is spelled N1QL. It stands for Non-First Normal Form Query Language. NQL is similar to SQL, but with extensions specific to the structure of JSON documents. The TDV Couchbase adapter is important to our customers in many use cases. In a complex modern enterprise, data from Couchbase often needs to be integrated with data from other sources, such as relational databases, flat files, web services, and so on. TDV enables this integration by rendering Couchbase JSON data as standard relational result sets, making it possible to join Couchbase data with other enterprise data. Next, let's walk through a very basic demo of a Couchbase data source. Here is the business problem that we illustrate in this tutorial. Our business analysts need integrated views that join Couchbase data with other enterprise data, especially data from relational databases. We'll use the TDV Couchbase adapter to render the Couchbase data in a form that can be easily joined with other data sources. We'll begin by defining a Couchbase adapter in TDV Studio. Create a folder to organize your work, as shown here. Right-click the folder and select New, then New Data Source. Select Couchbase and click Next. Give the data source a name and enter username, server name, and password. Be sure to specify the HTTP protocol on the server. Select the Couchbase buckets you wish to introspect and click Next. Click Finish. Here's an interesting problem. One of our buckets could not be introspected because it does not have a Couchbase primary key. This is not a limitation of TDV. Couchbase buckets are not queryable until a primary index is created. Let's go to Couchbase and solve this problem. Log into your Couchbase console. Navigate to the Query tab. Couchbase confirms that the beer sample bucket is not indexed. Run this query to create the primary index. Now reload the browser page. Beer sample now appears as a fully queryable bucket. Now we can introspect the beer sample bucket in TDV. In the adapter, click Add Remove Resources. Beer sample is not selected. Select it and click Next. Introspection is successful, and all selected buckets now appear in the Studio namespace. Let's examine how TDV converts hierarchical JSON structures into flat relational structures. Double-click beer sample to open it in the Studio Enter pane. Click the Show Contents icon to return a sample of Couchbase data flattened into relational form. Let's compare this to the native data on Couchbase. Take special note of these columns, geo.accuracy, geo.lat, and geo.lon. Run this query in Couchbase. Note this structure. Parent geo has three properties: accuracy, lat, and lon. As we saw, TDV flattened this structure by naming the columns geo.accuracy, geo.lat, and geo.lon. Open the adapter in Studio and scroll down to find the Flatten Objects checkbox, which is checked by default. This option causes the flattening of the geo columns. Let's see what happens when we uncheck this setting. With the Flatten Object setting unchecked, we get a single column named geo. Double-click the first line of results to see it in detail. The entire structure is now returned as a JSON fragment. We have seen how to flatten properties, but JSON data can also contain arrays. How do we work with them in TDV? I've created an example bucket named Books. Let's see what the native data looks like in Couchbase. This structure includes two arrays, authors and subjects. JSON arrays are, of course, variable length, but this particular instance contains two authors and two subjects. Here is how that row appears in TDV by default. The array is simply reproduced as a JSON fragment. That's because the Couchbase adapter sets the Flatten Arrays property to 0 by default. Let's change it to 5 and see what happens. Now we see that in addition to the original authors and subjects columns, we now have 5 new columns for authors and 5 for subjects. Our sample record still contains the array fragments in the original columns, but the array members are parsed into the first 2 of the new columns, with the JSON punctuation removed. The last 3 columns are null because there is no data to parse into them in this particular record. Here is another record that contains 6 subjects. Because we set the maximum array length to 5, the first 5 are mapped into columns. But if you wanted the 6th item in the array, you would have to parse it from the subjects column using a SQL function in TDV. Finally, let's look at how you might use packaged queries in TDV if you want to take advantage of the native capabilities of Couchbase's Nickel query language. For example, this Nickel query uses its extended syntax to specify items from an array, which of course is not valid SQL. If you are not familiar with TDV packaged queries, please see the tutorial on that topic. Here we create a new packaged query, bind it to the Couchbase Data Source, and enter a Nickel query. On the Parameters tab, we use the Design by Example feature to automatically create a cursor. We can now execute the query and get results. As of this recording, Couchbase packaged queries are restricted in some ways. For example, use of column aliasing, although valid in Nickel, is flagged in TDV. Be sure to test your packaged queries carefully to make sure the syntax is acceptable. We have seen how to access data from the Couchbase adapter and how to use it with packaged queries. Our demo is complete. Let's summarize what we have seen in this tutorial. Couchbase is a NoSQL database that stores data as JSON documents. Couch is an acronym for Cluster of Unreliable Commodity Hardware. Couchbase is schemaless, making it very easy to extend documents by adding new data elements over time. Related documents are typically stored in individual databases, which are called buckets. Couchbase provides a query language called Nickel, which is spelled N1QL. It stands for Non-First Normal Form Query Language. Nickel is similar to SQL, but with extensions specific to the structure of JSON documents. The TDV Couchbase adapter is important to our customers in many use cases. In a complex modern enterprise, data from Couchbase often needs to be integrated with data from other sources, such as relational databases, flat files, web services, and so on. TDV enables this integration by rendering Couchbase JSON data as standard relational result sets, making it possible to join Couchbase data with other enterprise data. As you use the TDV Couchbase adapter, keep these key takeaways in mind. The Couchbase adapter's default behavior is to flatten nested properties. If you wish, you can disable this behavior. The adapter's default behavior is not to flatten arrays. You can turn flattening on by specifying a maximum array size to use for flattening. This array size is set at the adapter level, so if you want to use different values for different Couchbase buckets, you must define multiple adapters that point to the same Couchbase instance. After completing this tutorial, you are ready to integrate Couchbase data into your enterprise. You can leverage this knowledge and dive deeper into Couchbase's NCL capabilities. You can also begin learning to use other NoSQL data sources with TDV, such as MongoDB. Thank you.